Hello, I am Jeewon Lee, and this is ReVIEW, a remote inspection platform that combines 3D reconstruction, object detection, and web-based visualization for safer and smarter inspection. Before heading in, I want to mention 3 different scenarios that have challenges for on-site inspection. Industries like ship engine rooms, nuclear power plants, and high-rise buildings pose extreme inspection challenges due to safety risks and high costs. To give a specific understanding of where it could be utilized, ReVIEW utilizes the challenges of ship inspection. Regular inspection and maintenance of ship engines are critical for ensuring safety, reliability, and efficiency in maritime operations. Neglecting these inspections can result in machinery failures, increased operational costs, environmental hazards, and significant safety risks. However, routine maintenance is not without its risks. Traditional inspections have led to severe accidents, such as a fatal incident aboard a Caribbean cruise ship where a pipe explosion claimed lives, and the tanker inspection accident where a second engineer suffered severe burns. These examples underline the dangers of physical inspections in hazardous environments. But not only this, the challenges of inspection exist not only in the dangerous environments, but in the case of ship engine room inspection, where frequent and regular inspection is necessary. The ports are far away from the headquarters, so it is physically hard to be present very frequently. This is why remote inspection is critical. By eliminating the need for physical presence, remote inspection technologies address safety concerns and logistical inefficiencies, reducing the costs and minimizing risks in hazardous environments. These systems offer a safer, more cost-effective alternative to traditional practices, mitigating operational challenges and protecting the lives of those ensuring maritime safety. ReVIEW guides users through video capture, detects key components using YOLO, extracts camera poses through structure from motion, and reconstructs a 3D model using 3D Gaussian Splatting. All of this becomes viewable interactively on the web view through WebGL. So the very first thing we tackled was a guided data collection strategy, basically a step-by-step walkthrough for on-site engineers who aren't 3D experts. It might sound like a small detail, but it's actually the make or break step. So if the image data aren't high quality and don't overlap enough, the structure from motion initialization for Gaussian splatting simply won't mesh. Getting this right up front means the rest of our 3D Gaussian splatting pipeline can run smoothly and produce accurate models. Structure from motion requires overlapping visual features, so we ensure proper image overlap with a capture strategy customized for tight spaces like ship interiors. In type ship environments, random filming fails. We designed a strategy that ensures enough overlap by considering the object size and the camera specs. Using the pinhole camera model, we derived an exact tilting and angle formula, considering camera specs and scene geometry to guarantee an optimal frame coverage for reconstruction. Now that the images are collected using the data collection strategy and uploaded on the ReVIEW platform, the second thing that it undergoes on the web is extracting the inputted video data into frames. The system starts with video upload, extracts frames, applies image and distortion, filters out the blurry ones, and feeds everything into the structure from motion and the YOLO modules. We use CoMap to extract camera poses and initialize Gaussians. Then a 3D Gaussian splatting training loop refines the positions, colors, and the shapes to match the ground truth visuals. YOLO detects and classifies components in each frame. Those detections are then linked with the structure from motion camera poses to enable instant localization inside the 3D model. With the incorporation, this is what the ReVIEW platform looks like. Clicking on any components button takes you to the exact 3D location where it appears, creating a seamless transition from the image to 3D inspection. We tested our capture strategy with different camera distances. A 2.0 meter distance gave the best overlap and PSNR performance, indicating a clearer reconstruction, which aligns with the results that we obtained from the calculation through the equation that we gave. We also found that about 200 to 250 image input frames gave the best trade-off between the model quality and the processing time. Our WebGL viewer sacrifices some precision for accessibility, but performs well between 10,000 to 15,000 training iterations. It supports real-time inspection without needing heavy software or GPU-based renderers. Compared to local viewers, WebGL trades off some rendering quality for real-time performance. We optimize settings like the training iteration and the Gaussian count to balance the speed and visual fidelity. We observed that training beyond 15,000 iterations offers minimal visual improvement in the WebGL viewer. The best balance of the sharpness and the performance occurs between the 10,000 and the 15,000 iterations. Across different camera views, WebGL shows close alignment with the ground truth, especially within the optimal iteration range. While PSNR improves with iteration, structural similarity, the SSIM, peaks earlier, highlighting a quality performance trade-off. Overall, ReVIEW integrates data collection, 3D reconstruction, and object detection into one scalable web system. While it currently uses standard 3D Gaussian splatting, future versions may adopt different Gaussian splatting strategies and improved rendering for even sharper and real-time inspection. Thank you for watching. ReVIEW brings high-fidelity 3D inspection to your browser. No special tools, no on-site visits, just your camera and just a click. Thank you.